Now they can. Okay, here we go. The ratio of the angles of the triangle is a 2 to 7 to 11. 2 to 7 to 11, like it. Find the measure of the angles. All right, what do you do here? Well, it's real easy. The nice thing is this. It's ratios. These are not the angles. Again, you can draw a picture of how you don't need to do here. But these are not the angles. Obviously, it's not. These are all being increased by the same amount. Do I know what that amount is? No, I don't. But since they're all being marked, I'm going to say a 2x plus a 7x plus 11x is equal to something. There was nothing given to us. But what do we know that the sum of the angles in a triangle is? 180. There's going to be 180. Nice job. Again, when we first do this, it's an elongated problem. We don't like that. So they're always going to smush together here when I do so. 2, 7, 11 gives me a, 9 plus 11 gives me a 20x is equal to 180. Last step, divide by 20. X is equal to, what's half 180? Well, not half 180, but what is this going to be? What? Not you said 90. 9. Okay? Yes. Threw me off there. Okay? It's going to be 9. So we're done, right? Fantastic. Moving on to the next problem. Go on to number 2. No. What? How dare you tell me no? I'm the teacher here. What else do I need to do here? Plug it in. I got to find out what those angles are. So again, once I have it, I'm going to take this 9 and I'm going to plug it back in to those various x's over there. All right? So the first one, I'm going to do 2 times 9. Give me a number. I will do 7 times 9. Give me another number. And I'm going to do 11 times 9. Give me that third number. 2 times 9 is 18. Awesome. 7 times 9, get your fingers out. Hold down your 7th finger. 63. I got it. I know the 9's trick. 63. And the last one. Nine. What's the answer? What's 11 times 9? 9. I was tricking you. So yeah, make sure you guys know. Now I'll just color. I don't have the right colors now, and I guys are really throwing me off. So 99. Great. Those are all my degrees. How do I check myself? I want to check myself. Add them back up, see if they equal that magical 180. Hey, guess what? They will. All right, questions on those? You had one very, very similar on your little check we had the other day. Any other questions? Any other questions? 3, 2, 1. Number 2. All right, so determine the following figures are similar. Circle yes or no, then state what theorem you use. So we can't use a shortcut in this. If you did not use a theorem, leave it blank. So let's check our work. All right, I like to do a little pre-read here. Remember those shortcuts. We have those 3 shortcuts. Side, 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 angle, and angle, angle. Based on before that doing any work, what could this be if we know we have good ratios here? Side, 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 because I have 3 sides. So let's go ahead and check these, and let's see they match up. This is where a lot of students tend to make mistakes because they think the triangle's always oriented the right way. It's not. So let's go left to right, just for me, and let's pick the smallest side in the left triangle. And what would that be? 4. So I'm going to do 4 over. What is the smallest side in the other triangle? 10. Let's figure out that ratio. Let's reduce that fraction. Those of you borrow our calculators, do it on there. That's the calculator you get to use tomorrow, or buy your own. Halloween's coming up. Get ready. So 4 over 10 reduces to 2 over 5. However you want to think about it. 2 over 5. Awesome. There's the first one. Well, I can't finish. I got to keep going. Got to keep going to the next one. Let's pick the next smallest side of the left triangle, because I'm always going left to right first. The next smallest one would be 10. 10 matches up with what? What's the next smallest side of the other one? 25. What does 10 over 25 reduce to? 2. 5 goes into both of them. Goes in 2 times here. Goes in 5 times there. So far, so good. Can I stop right there and not go any further? I gotta check to see if the last one's gonna work too. So the last side, again, you want to cross them off as you go. So if you memorize it, that's fine. The next one's going to be obviously 16 over 40. All right. Will this reduce down to the appropriate answer? Lauren? it reduce to? 2 over 5. So are all the sides proportional to one another? They have the same ratio. Yes. So are these triangles similar? Yes. And you guys already gave me an idea what it's going to be. Yes, Ben?
How are we supposed to know which way goes up?
Great order. That's why you said. Again, if you just looked at it as it is, it's a great question, Ben. If you looked at it as it is, it's kind of like an Ender's Game situation here. Which way is up? Which way are we oriented? You got to think about that. Which way is the gate? The gate is down. All right, what I'm thinking here, it looks like 16 goes to 25, 10 goes to 10, 4 goes to 40, right? That's why we say take the smallest side to the smallest side. So the smallest side here was 4. What's the smallest side of the other one? 10. So it's kind of rotated 1 degree, 90 degrees that way. And then so on and so forth, go through. Well, 10 goes with 25. 16 goes with 40. So that's the way of looking at it. Yes? You can do it. It doesn't matter how you do it, but yes. That's the way we keep it in order. So I say, what's the smallest side? Because I don't know how it's oriented. It's not always oriented the right way. So the smallest side always matches up to the smallest side. The medium always goes medium, large goes with large. So that's a great way of always sticking it together. Because right now, if you did this as you saw it, it would not be similar. But since they all have the same ratio, these will be similar. What 3 pieces do I have? What do I have? What was I given? Side, side, side. We already established that. What do I need to include on this statement? Similarity. Easy points, don't miss them. Okay, this whole unit similarity, put that squiggle there. If you don't have that squiggle, it's saying that they are congruent. They're obviously not congruent, they have different measures. Okay, good on that? Awesome. Numero 3.
So look at number 3. Again, we have to determine if they're similar. Well, we take the sides, set up our ratios. In this first triangle, which side do we want to put in the top? Anyone? Okay. 15. Which side in this other triangle is going to match up with 15? What is it? 10. Good. Small side matches up with the small side. Okay? Well, what does 15 over 10 reduce down to? 3 over 2. I like to scratch them off as I go so I don't accidentally repeat. Go ahead. How do we set up that next one? Okay? Yeah, 18 over 12. And what does 18 over 12 reduce down to? Yeah, 3 over 2. So the sides are proportional. And if you notice, the angle in between those two sides are the same. So can we say that these triangles are similar? Yeah. What little theorem or shortcut did we use to show that these triangles are similar? Side, angle, side. Very good, Caitlin. I like how you said similarity. Make sure you have that squiggle afterwards. Question. So here, if you notice, what parts were we given? Were we given any sides at all? No, we were just given what? Angle. And if you notice, these two angles are the same, but these don't necessarily match up. But can you just say no and move on? Is there something we can do to maybe figure out what those other angles are? Any? Yeah, do 180 minus these two angles, and that will give you that third angle. And if that third angle matches up with this one, then you know they're similar. If it doesn't match up, then you know they're not. What do we get? We get 45. So these two angles match up. These two angles match up. So can we say that these triangles are similar? Yeah. By what theorem? Angle, angle. What do we need afterwards? Similarity. Okay? If those angles didn't match up, you would just circle no and move on. Or if the sides were proportional, you would just circle no and move on. Okay? Do you notice here? Make sure to study the side splitter theorem proof in your notes. It is found in 3.4 of your notes. I believe to do it on your test. Just saying, you might have to. I will go back and re-look over it so that you know how to do it first one. Questions? Number 5.
We number 5 already? Time flies when you're having fun, I'll tell you what. Alright? So, we have each of these polygons, we know they're similar. Solve for the variables. Alright, who's got a plan here? Who's got a plan? We know they're similar, so what are we probably going to set up? Not all at once. Sit down. What? Yes, the city, you're saying it. Proportion, why not? And it looks like they're oriented the same way. Alright, they're facing the same direction, so we don't have to worry about that stuff. So whenever I'm saying proportion, I need to figure out, I need a constant. I need a side that I know is matched up in the right area on both sides, and I have a value for. So who would like to pick one of the sides in this triangle, or this quadrilateral over here? Pick me one of the sides. Oh, Lauren, thank you for raising your hand. Pick one of those sides, and the left one for me. 10, good call. So I'm going to say 10 matches up with what? If she said 10, what other side matches with 10 on the other one? Jacob? 10 goes with what? Yeah, it goes in the same order. 10's right there, 5's right there. They match up. All right? Well, now we got to solve for x. Since we went left to right, well, the x is sitting right there. So I'm going to say, well, that angle. Oh, what am I doing? I'm doing it more than I have to, don't I?
Yep.
Wow. Didn't even read the question. Went right through it. Don't even need to do that. I was going ahead, above and beyond, because I know angles are congruent in polygons. I'm just so used to doing proportions, that's what I went and did. But I'm not going to do that. You could, but I will do more work than I had to there. But I do know that angles are going to be congruent. So I can say that angle is congruent to that angle. So I can now say that 3x minus 9 is equal to 42. You would have got it the other way too, just been a lot more work. No big deal though. Now I have that magical bear problem I've been dreaming about. Let's add that 9. Add 9. So I have 3x is equal to 42 and 9 gives me a 51. Last step. Divide by 3. Whoa! 17 I hear. So x is equal to 17. Nice. That's it. More work than I had to. Alright. Next one. Boom! So over here, number 6. Now, I don't have the angles, now I have sides, so I'm definitely going to have to do proportion here. But this goes back to what Ben said earlier. Which way's up? How do I know? Well, we look at the angles. The angles will tell us where things are supposed to be at. So you guys, it's nice because you guys can flip your paper and rotate different ways, but I can't do that. So let's figure out what we want to solve for first. Do we solve for x or y first? Well, let's go for x first since it's the first one listed. Here's my x. All right, see where it's at. All right, got it. Where does that x match up with on the other side? That x goes with what other side? Shane? The 5, right? If I rotate this around, and again, I just go left to right, but if some people like to go right over left, it doesn't matter. Just stay consistent. So I'm just going to stay consistent so we do everything from left to right so you guys get in that habit. So I'm going to say the side that matches up with 5 over, you guys told me that x is on the other side, 2x minus 6. That is equal to. Now, the other ratio I need, usually this one I do first, is the one that I know both values. Well, obviously I don't know why. I don't know what it is. So it's got to be this 9. What does the 9 match up with in the other figure? What? 8. 9 goes with the 8. So I did 5 over 2x minus 6. I left to right. Come back to my left triangle. It's 9 over 8. This is the one I know all the values for. It's the same. There should be a little red flag going up in your mind. What should I do here as my next step? David, thank you. Do you know what I need to do here to help myself out? Well, yes, I do need to cross multiply. But right before I do the cross multiply, and you don't have to do this, but it's a great way to keep you on track. What do I need to do? Derek, yeah, you're right, it's going to be cross multiply. Parentheses. So put it in parentheses, then I'll do it. David said, and I'm going to cross multiply. All right? So this, when I do this, this helps me make sure I distribute to both parts. So go there to there, there to there. Let's go. What's the next ratio? What is 5 times 8? 5 times 8 is 40. So 40 is equal to, now I'm going to do this one. This is why I put in parentheses, so I don't forget it. It's going to be 9 times this whole thing, the quantity of 2x minus 6. That. How do I solve something like this? Distribute, make it rain. Okay. So now I have 40 is equal to, not 9, what am I thinking? Can't multiply. 18x minus, here's a 6 track, hold down your 6 finger. What? 54. So he said, I feel like you said a 2 in there somewhere. I feel like you did. Alright, now it's that paired problem that we want. Let's go through. There's no x's, x stays there. Let's add this 54. Add 54. So now I have 94 is equal to 18x. Last step, let's divide by 18. Divide by 18. X will equal this magical number of, Emmett, 5.2. Wait a second, Mr. Carnes Baker, that's a decimal. It's got to be wrong. Now we're gonna get into the field where we do more decimals. Now, they're gonna be nice decimals. We're gonna stop at 1 to 2 decimal places. If they're going on forever, being irrational, not making sense, that's where you made a mistake probably. But if they stop right here or to the 100 spot, 2 decimal places, then you're pretty good. All right. Well, let's go back and let's figure out what y is. We know what matches up. Let's go ahead and solve this next one here. So, the y, however you want to look at it. Let's go left to right. I want to solve for y. What does y match up with in the other triangle? Basically the number we haven't used yet. Lauren? 12. So it's going to be y over 12 is equal to. And now we're going to go back to that. What side do we know in both of them? We already used it once. We're going to use that same ratio again. What ratio did we know in the original one that we do both the left side and the right side? 9 over 8. We knew that side. Those are the sides that didn't change. You could go back there and figure out what that is, but it's much easier to do this one. So we're going to go ahead and cross multiply like we should. No parentheses, no binomials, so we know it's just going to be by itself here. So we do y times 8, 12 times 9. Let's go. So I'll help you out with the first one. It's going to be 8y is equal to 12 times 9, 108. Good job with your 9's tables, guys. The last step, divide by 8. Divide by 8. So y will equal this number. Yes! 13.5. That's a nice number. It stops right there at 5. It is a decimal, but it's a nice looking decimal. 13.5. Questions? Setting up proportions. Nothing? Nothing? Cool. Siete.
If we look at 7, it says by using the proportional perimeter theorem, find the perimeter of the second triangle. Again, whenever we're solving these problems, what are we going to set up? A proportion. Always when you're solving, unless really you're dealing with angles and this unit, you won't really be setting up a proportion, but with sides, set up a proportion. Okay? Well, if we look here, what's the only side we were given? 7. Over which side matches up with 7? 15. And if you're not sure, 7 lines on a line that has no arcs and 1 arc. 15 also lines up on a line that has no arc and 1 arc. So 7's going to match up with 15. Perimeter. We're dealing with perimeter. Well, we're trying to find the perimeter of this triangle. What can we represent that with? 15 times x is just 15x. 5 by 15. X is equal to what? 357 divided by 15. 23.8. Again, these little decimals are okay. If you're getting really little big long ugly decimals, make sure you double check they're working right. So again, it's the one side you were given over the matching side is equal to the missing perimeter over the perimeter of the other triangle. Cross multiplying something. Okay? So our answer is 23. We look at 8. Again, what are we setting up to solve these problems? Every time. A proportion. Fraction equaling a fraction. Every time. That's what you will be setting up. Okay? And it really doesn't matter how you set them up. I'm trying to find x, so I always just want to make sure that's there. I just put it first just to make sure I have it. Which part matches up with x? 3. That's going to go on the bottom. Okay? Then it really doesn't matter how you set this up. What other part do we have? Does 9 match up with 34 though? 9 is on the side that has that right angle. Is 34 on the side that has that right angle?
Oh, I thought it was more like the numbers.
You can, but we don't know what this other side is. So right now, yes, it'd be 9 and 34 because of size. But we don't know a third side. So 9 actually would match up with this side because of the right angle. So make sure if you had given all 3 sides or 2 sides, then they match. But something like this, 9's right underneath the right angle. We don't know what side matches up with 9. So Derek, what side do we have to use then? 5, 34, and 6. They look like they're in the same spot. They would match up. Okay? And good. X was in the top, so the triangle that has X has to go on the top, and then 6 would go on the bottom. And then you just solve. 6 times x is 6x. 3 times 34 is what? 102. And then what do we have to do with the 6? 102 divided by 6, x equals what? Questions over that? And you just match up the missing parts, set up the proportion, and solve. Okay? Let's go ahead, skip 9. 9 is literally the same exact steps as 8. And if you need another answer, it's 3.6. So if you try it on your own and you want to check your answer, that's what you should get.
3.6. Boom. This guy. Find the missing link. All right, let's go ahead and do so. Again, what do you think we're going to do? We got a lot of parallel lines, got some transversal there. Ultimately, what are we going to try to set up here? Again, I feel like it's a broken record here. Proportion. So let's see what we know here. All right. Well, it's kind of written how it matches up with one another. Bless you there. So I'm looking for this. I don't know what it is. I'm going to call that x. So I'm going to say x over what? What does x match up with? Let's do the other side. X goes with what? 30. Yeah, x goes with 30. And the other side, that's going to be equal to, if I do that pattern how I did, I said x over this, then I got to go this over this. All right, well, I know that bottom's going to be 25 for sure. But how do I figure out what that missing piece is right there? Okay, got an idea? Okay, well, then?
X minus y.
Yeah, well, x minus y, good. I like the minus thing in there. How long is that whole segment? 77. So I want this piece. I don't want that piece. So how can I get rid of it? 77 minus x would give me what that value is. So I'm going to do 77 minus x would be that value. So 77 minus x would give me that. If it's not x, it's got to be what it's going to be. So now I have my ratios. Just like we talked before, I now have a binomial. So I'm going to put in parentheses just to keep myself organized. And I know that reminds myself of what I need to do as my next step. So let's go. Do some cross multiplying. There we go. There we go. Got it. So when I do so, the first one's going to be 25x. You're welcome. Since I put this in a parenthesis, it's just really smush them together. 30 times the quantity of 77 minus x. That gives me a little idea of what do I need to do next. My next step better be distributing or something's going on with me. So make it rain, make it rain. This still remains 25x equals, what is 30 times 77? It's a great number. It's my high school football number. It's got to be a good number. Yes, let's go with Emmett. 2, 3, 10. 12,310 minus, make sure you distribute to the second part. That is the most missed question, is you don't distribute a 30 to the x, or whatever the second term is. So it's going to be a 30x. Alrighty. There's our bear problem we want. Two-stepper. It's got an x and a number without it. Well, looks like we got some x's. Let's move the smaller x first. So that's going to be a add 30. Add 30x. So guess what? Keep going. And now I have 55x is equal to 2310. We know the last step is going to be divide by 55. So x will give me this handsome number of 42. 42. So x is 42. There's another way of setting this up that some people like to do, and you just have to do a part. I would do the x over 30, and then I would do the whole side. So if I did x over 30, and then I would do 77. The piece I have, I would do x over 30 is equal to, now let's talk about the whole sides. The left side is 77. How big is the right side? 55. Look at those numbers you get. You get the same numbers, just written a different way. Cross multiply, divide. Whatever you want to do. Multiply things. Okay? Questions on 10? 2 already? Oh, there we go. Let's get 9. Alright, this guy. 11. DE is a mid-segment. Alright. What does it need to be a mid-segment? What does a mid-segment do to either side? Think about mid-segment. Cuts it in half. So each side is cut in half. And I also know something special about this mid-segment, but let's focus on the half part. So DE cuts each of those sides in half. So what do I know about DA compared to DB? Well, I know their values are the same. And conversely, on the other side, I know this side is going to be congruent to that side. The sides are the same. That might make it really easy to figure out what y is. So with that knowledge, how can I solve what y is? Leah? Because I know their values are the same, I can set those two equal. So I'll do that first. Again, it doesn't matter what you solve for first, x or y, but I'm just going to go ahead and solve that. So 2y minus 3 is equal to 7. Easy little two-stepper. Add the trace. Add the trace. 2y is equal to Pace. Divide by 2. What's half of 10? Carl? Oh yeah, 5. Good call. 5, and this gives your y. So I got y. Now I'm going to figure out x. So this is the other part of what a midpoint is. Or mid-segment, excuse me. This is the other part of what it means to be a mid-segment. What do I know about this segment relative to that bottom segment, that base segment? This is half of that. So if this is half of this, well, really all I know is this is equal to 2 times that, right? Or some of you guys can figure in your head what that is right now. But I was going to set an equation. This is equal to 2 times that middle segment. So let's write it. So x plus 1 is equal to 2 times that middle segment. And that middle segment happens to be 3. It's the rule. Mid-segment, it cuts the sides equally, and this is half as much as this base. Or the other way around. Multiply this by 2, you'll get how long that segment is. Always. That was one of your skill check. I think it was the number 1, 2. The number 2 question yesterday, we had that picture. It said below is 18. What's the bottom? It's 36. You just double it. All right. So all we're doing is doubling this. Well, we know this is going to be 6 ultimately. So I'm going to have x plus 1 equals 6. And some of you probably do this just by looking at it. One last step. What's going to be our x? X equals 5. 5 again. This is always half of what that base is. Sometimes you're given this base and you're going to find the mid-segment. You just divide by 2. Just depends how it's given to you. Okay. Next one. The next one. What is it? Just get something right here. Oh, picture. Picture.
Okay. If you look at 12, since you wanted to determine the height of your school building casts a shadow, a 6-foot shadow at the same time you cast a 1.25 shadow. You are 5 feet tall. How tall is the school building? Okay, again, draw a picture. Essentially what you're doing, you're drawing one little tiny triangle and then one big triangle. Okay, you are representing the little triangle. Okay? This part right here is you, and you are 5 feet tall. The bottom part is your shadow, which is 1.25. Okay? Your bigger triangle is representing the school building. So the part that's going up and down is your school building. We don't know what that is. That's what we're trying to find. The bottom part, again, is the shadow of the school building, which is 6 feet. And then this part is the sun rays. Doesn't really matter. We draw it for the triangle purpose. Again, when you're solving these problems, what do we always want to set up? Fortune. Okay, how are we going to set it up? There's multiple ways. As long as you're consistent, you're right. How do you want to set up that first fraction? Emmett? Quick. 6 over 1.25 is equal to, how will we have to set up the other one? See? We did 6 over 1.25. We have to do x over. You could have done 5 over x is equal to 1.5 over 6. You could have said x over 5 is equal to 6 over 1.25. I mean, you can mix it up, you're fine, as long as you stay consistent.
Keep it the same throughout, you'll be fine.
And then
flip it, you'll be wrong.
cross multiply. 6 times 5 is 30, and then 1.25 times x is 1.25x. And then what do we have to do with the 1.25? We're going to divide. Divide by 1.25, divide by 1.25. So x is equal to what was 30 divided by 1.25? 24? 24? It'll be 24 feet. That's all your whole building is.
The whole thing is 6. So actually 5.
Questions over that?
If I did times 2. Not the second.
And now we're going to skip this one. If we have time, we'll go back to the ones that we skipped. We kind of ran out of time third period, so make sure we get to all this stuff.
Yes. Jump to 14 real quick.
For 14 is to determine whether the polygons are similar. So do that first. If so, write a similarity statement and give the scale factor. Okay? If they aren't similar, explain why. Well, show that these figures are similar, you're going to set up ratios. We have 4 sides, so we will have 4 ratios. Okay? How do I set the first one? Really not wrong. How do I set the first one? Give me one side in that first triangle. Doesn't matter. 28. What between two arcs match up. Okay? And big side always matches up with big side. What is 28 over 35 reduced down to? 4/5. Okay? And I like to cross up as we go so we know we're done. So, give me another side in that first triangle. Okay? Good. 20. And again, Derek, which side matches up with 20? 25. What is 20 over 25 reduced down to? 4/5. And mark them off as we go. And then what's another set? Give me another side in that first triangle. Same? Good. Over 15.5. What is that reduced down to? Can't use the ABC button in your calculator because we're doing decimals. You have to use the division sign and convert it to a fraction. What is that reduced down to? As a fraction. 4/5. And this last one, these last sets, the exact same. It's 12.4 over 15.5. It's the exact same. You don't really have to do any math there. It's going to be 4/5. They're exactly the same. So are these similar? Yes or no? Yeah. Why? They're the same. So once you determine whether or not they're similar, you have to first write a similarity statement. It's a little different because it's a four-sided figure, technically a trapezoid. So we would just abbreviate it with trap. And then name that first one however you want to name it. Doesn't matter. How do I name that first one?
Anyone else?
BCAD. Remember? It's similar to trapezoid. If we went DBCA, how do we have to name the other one? Careful. Should be X, Y, Z, W. So we started with B. You have to flip it to match up, so B matches up with X. And it all kind of falls into place after that. What did we do? Oh, we went, well, if we flip it, it would be XWZY. Yep. XWZY.
Yeah, that's what I say. If you do a flip 180, that's what it is. But if you do a rotation, like it'd still be right the other way. But yeah, either way it's fine.
Okay. I just visualized it.
Yeah, you flipped it over the X. That's fine. But if you rotated it, it'd be the other way. Either way it's fine. I think either one's acceptable.
I don't like this one.
I'd flip it.
Yeah, I flip it. Alright. So we wrote our similarity statement. What else do we have to do? Scale factor. What is the scale factor? 4/5. Good.
You already have it.
Don't just think, oh, scale factor right there. Similarity statement. Good. You have to say scale factor 4/5. You have to write it. Don't just assume that we know that you know that's the scale factor. You have to state the scale factor in the fraction. Good. I don't know why we're necessarily backing up. We aren't really done. We still have 3 minutes of your time. And we still have one to go over that we didn't get to. That would be super helpful for your test tomorrow.
Yep.
We said the answer should be 3.6, so let's check. How do we set this up? Again, multiple ways. We want to set up a what? A portion. How are we going to set it up?
X over 12.
Perfect.
And then 4.5 over 10. 10 over
4.5 over
12.
in the same spot. Good. The missing piece over the matching side, and then you could have, doesn't matter. You 4.5 over 15, you could have done 3 over 10. That doesn't matter. Okay? And then you just cross multiply and solve. So It's just 15x. 12 times 4.5 is what? What is it? 54. And then what do we have to do with the 15? Fine. What is 54 divided by 15? 0.6. So we know we did it. That is missing side matches up with missing piece. Piece matches up with piece. Cross multiply and solve.